Welcome to the next video lesson on wiring in computer engineering. The materials that we're going to need, as you can see in the picture, are three different tools. So starting from the far right, the wire strippers, which are going to remove the insulation off the wire, the diagonal cutters, these ones right here, and then the pliers to the left. You have one more tool in your kit, which is an IC remover. You will not need that for this exercise. We're going to be using 22 American wire gauge, or AWG. 22 is the measurement, the diameter of the wire, and the thing about AWG measurements are that the higher the number means the thinner or the less diameter the wire. So 22 is quite thin. If you want something thicker, you go to a lower number like a 14 would be something you would see probably in your house that would carry AC current. And then you also obviously need your breadboard. Okay, so for measuring wire, this is what we're going to do here. Our goal is to connect a wire from column 5 in our breadboard to column 10. And to do that, we're going to cut the wire so that it extends 2 holes beyond 5 and 10. This is one strategy and one technique I'm going to show you in a minute. You can secure the wire very easily with your pliers. I would not advise you to use your fingers, particularly for small wires like this, because they'll slip out, and that's what the pliers are for. They're to help you hold on to that wire while you're removing it with your wire strippers. And you can see it's 5 millimeters that you've removed of insulation on either side, thus revealing this copper conductive material underneath, which is what needs to be connected into the breadboard. We're going to bend the wire at 90 degrees on both ends. Okay, so you see that there are no burrs or kinks in the wire, and that will help it insert into the breadboard much easier. Okay, and when we insert it in, you can see that it's nice and flat to the breadboard on top, and you don't really see much copper at all. Okay, so the goal for us right now at this point is just we're going to start very simple, and we're going to try and connect a wire from column 5 to column 10. So column 5 is on the left side here. You can see it's numbered from 1 all the way to 60, which is way down here. So we're going to go between 5 and 10, and the way we're going to start with that is by removing some of the insulation on this wire. There's a couple ways you can do that. You can take off roughly 5 millimeters is what you want to start with, exposing the copper underneath. Now, the reason why I know it's 5 millimeters, I've just been doing this for so long, I know exactly how much to take off. For you, it might be a matter of actually getting out a ruler and measuring that 5 millimeters just to see. So if I took my ruler here, my fancy sparkly ruler here, and I just laid it down, I'd see that, yeah, that's about a half a centimeter or 5 millimeters. I can also determine that it's 5 millimeters simply by seeing that it spans across 2 holes on my breadboard. Okay, so if I zoom in there just to see what that looks like, you can see that that's 2 holes on the breadboard apart. Okay, all right. So the next step, there's two ways I can do this. I can insert the copper end into my 5 hole, which is what I'll do here. And let me just remove this larger piece so I'm not hanging on to all that wire. So if I take that 5 and I insert it like this, okay, you can see I'm going to bend this over now so it's nice and flat. Okay, so if I turned it on its side, you see that that is actually nice and flat on the breadboard. And I can now look down and see that 10 is where I want to be, but I know I have to take off some insulation, and I have to have copper that's going to be part of that wire, right? So I need to account for that, and the 5 millimeters, which is going to be in addition to this 10, is going to be 2 holes past, and I'm going to use my diagonal cutters to cut it like this. And all I'm going to do is simply take my wire strippers and again find that nice 5 mm distance, and I'm going to remove it. Okay, just like that. And I'm going to make this U shape by bending, okay, the wire up like this. Okay, so what you get is something that looks like that. And that's a nice wire because it's straight. You can see that there's no kinks or anything here. There's no burrs on the end. So it's going to hopefully get to go, it's going to easily insert itself into the breadboard. Okay, the other technique that I can use, which is very similar, is I'm going to remove my 5 mm like I did before. Okay, and I'm simply going to lay my wire across 5, okay, to 10, and then I'm going to, you notice that it starts here, so that's where my copper will go into 5, all the way to 10, and I'm going to account for that additional 2 holes on the other side of 10, okay, and I'm just going to cut it with my diagonal cutters there. Okay, comme ça. Now again, I'm going to use my trusty pliers to secure the wire so that I can remove those additional 5 mm on either side. And then I'm going to use my pliers again to bend the wire, the copper, at that 90-degree angle. Okay, and that way I come up with a nice wire like that. So we're going to try and insert it now. So I can pick it up with my pliers or I use my fingers. If I come across here, I can see now just on an angle there. If I just tilt that up for you to see, you'll see how that goes in really nicely. Okay, because there are no burrs or edges, and it just slides right in there, and it's nice and flat to the breadboard. You can see that. Okay, and one of the characteristics is I can easily remove this. Okay, and then put it back in. It's quite simple to do that. Okay, so some characteristics of good wiring are that the wire is flat to the breadboard, as you can see here. We have very little copper showing. All right. An important one is that insulation is not forced into that hole. Okay, that could create some problems. It's vertical or it's horizontal, so you want to avoid diagonal wires, so you could do it this way if you wanted to put it across, for example, right, that way, or which is vertical, or you could do it horizontal as I had before. We don't cross over chips, meaning that if I had a chip in the middle here, I wouldn't cross over it. For example, if I put a chip here in my breadboard, right, like that, I wouldn't want to have my wire over the breadboard, right? Because if I needed to remove the chip, I would have to remove the wire with it, and that would be not a good thing because I'd have to redo it. So we don't want to go over chips like that. We want to go around them in a vertical and horizontal manner. And then sometimes you can color code your wiring to identify different sections of the circuit or to identify inputs as opposed to outputs.